All right, so if there's a calculator guy next to you, you need a calculator. So this problem, sine 2x equals negative 0.21. We have almost the same problem as number 4, sine 2 theta equals root 3 over 2. So it's the same left side. It all depends on that right side, okay, or the other side, the constant, whether you use a calculator or not. The directions. What do the directions say? That says for numbers 1 and 2, we're going to follow these directions. This is the objective for the whole lesson, okay? Numbers 1 and 2. First, it says find the general solutions. Then it says find the exact values for either 0 to 360 or 0 to 2 pi. Once again, you never get to pick which one you like best. The problem will tell you. Number 1 says degrees. How do we know? Because it tells us. There is no C value. That is how you know. It will either tell you, or there's going to be a C value, the horizontal shift, the x-axis, and there will either be a degree sign or there won't. Okay, so you never get to pick. If it doesn't say, then you have to figure it out. Never get to pick your favorite. All right, so here all we're going to do is go y1, y2, and then find all the answers. So again, I would clear my calculator just because that's how it's going to be, and it's going to be easier. Now, maybe the window that you used on number 1 will help you for number 2. Maybe it will not help you at all, and you don't know how to fix it. So if you just clear it, it gets it back to normal. But again, it's up to you. If you're really good with the calculator, you might not need to do that each time. All right, so we're just going to put sine 2x, in y equals sine 2x and negative 0.21. And it says use degrees, so we want to be sure and be in degree mode, so our answers are not all wrong. And then we can graph it and see what happens from the window that is there. Maybe you have a nice window from the problem you did before, maybe not. I know that my second answer is going to tell me to find the values between 0 and 360. So I can use those general solutions too. So I'm just going to go to my window, instead of doing this a bunch of times, and type in 0 to 360, because that's really all I care about for the second part. And I can get my answers from letter A from that also. And then when I see this negative 0.21, that's really close to 0. So it's probably going to blend into the x-axis, and I want to be able to see it. So I don't want to see 20 units. I just want to see 2 or 4. So I'm going to say negative 2 to 2, just so I don't see so much, so I can actually see that line. It's just sometimes easier if you can actually see what's happening. And then graph. So there's sine 2x. Notice we went from 0 to 360, and there were 2 cycles because our frequency was 2. So here's 1 cycle, here's 2 cycles. Cycles happen more frequently for the frequency. B is 2, so that's why there are 2 cycles in 1 single rotation of the unit circle. That's what that number means. Whether you remember that or not, that's what happens. All right, so we need to find some general solutions. Notice we're coming down and up, down and up. So we can use these 2. We can use a down and an up. We can use an up and a down. This down and up. These back here, you use whatever ones you want. I'm going to use these 2 because then I'm going to need them for the second answer, and then I don't have to redo a bunch of work. So second trace 5. I like to scroll on my straight line because I get there faster. So the up or the down arrow gets you from one graph to the other. And doesn't matter what order you find them in. So there's one of my answers. So for general solutions, x equals, that first answer, 96.061 degrees plus, what's the period? Period equals 360 degrees over b. I write that every time, and I get it right every time. 180 degrees times n. And then I do that again for the next one, or the one before it or after. It doesn't matter which one you do, second trace 5. But again, I wouldn't go to the other one because that one doesn't help us in our second answer that we're going to have in a second. So there's the next general solution. X equals 173 0.939 degrees plus the period n. Do not write any more general solutions or you'll be repeating answers and then you'll get a point off for not simplifying. Okay, don't write answers that repeat themselves. 96, if you wrote the next one, 267.061, that is what 96 plus 180 is. So don't write any more general solutions for this one. All right, letter B says find all of the answers between 0 degrees and 360 degrees. Well, we already have two of them, 96.061, 173.939. And then we can keep finding the intersect, or to find the third, we can go back to what we do without a calculator. To find the third, we add the period to the first. To find the fourth, we add the period to the second, and you could do that forever since we know there are, since we know there are 4 answers, and the reason we know there are 4 answers is because when we look at our graph, that line, negative 0.21, crosses the function 4 times. So then your next one, you get 276.061 degrees and 353.939 degrees. So we've answered everything that it asks. All right, the next one, degrees or radians. It doesn't tell you, but there's a C value. Here's C equals 1. So that with radians, how do we know? Because there's no degree sign right there. If there is a C value, the directions will not tell you. You have to know. So we're going to plug this into Y1 and this into Y2. So again, I'm just going to clear the RAM right there just so it's a blank screen. So I have -3 tangent 2. I have to be sure and close my parentheses right there before I add 4, or that's going to turn into 2x plus 5, which is not the case here. And then we're going to put a 2. And then, again, I know that I'm going to, for letter B, find all the answers between 0 and 2 pi. So I'm going to go to my window right away, and I want to see everything between 0 and 2 pi, because the second answer says that. Okay, so that's what I want to look at to begin with. So I'm going to go ahead and graph it from there. Here's everything between 0 and 2 pi. There's the graph, and there's 2. So for letter B, we know we're going to have 4 answers. Letter A, we look at this. This comes down, 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 down. That's the same distance. So that's how we know we only have one general solution. Use any of those. Any of these, any before, after, doesn't matter. So second trace 5. Again, you can use any of them. I'm going to use the first one just because that's what I like to do. Any one you want. They'll all be the same value in the end, general solution-wise. So 0.865. X equals 0.865 plus the period. What is the period for this one? 90? So I'm going to say 90. Good, pi over 2. Okay, so pi over 2 n. That is my only general solution. Any other general solution would be repeating. We don't want to repeat general solutions. Because I knew what the question asked, that's why I did that first one first, because I know 0.865 is one number between 0 and 2 pi. And then I just keep doing that. Second trace 5, scoot over to the next one, enter, enter, enter. Well, there's our next answer, 2.436. Now, one thing that earlier a lot of people did not know this. So anytime you find an intercept, yes?
How did you know you only have one general solution?
Because look at that.
Because it's just all the same?
It's the same.
Okay. So because you add 0.865 plus the period, you get the next.
If I were to do that, I'd get the next one. Yep. If you add the period to the answer that you got and you get the next one, that's how you know not to put it. You don't want to repeat any. And tangent and cotangent are going to do that. When we look at this graph, see how it's the same versus the curve, which is up and down and up and down. And you have an answer on the way up and on the way down. Well, here all we have is the curve down, 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 down. So it's the exact same graph over and over again.
Hypothetically, if you would add that, you would get the number that's not the next graph, then you would have two general solutions.
Mm-hmm.
Okay.
Yep. Now, one thing. Every time you find an intersection or anytime you find a 0 or anything, the calculator's restoring x every single time. So if we went to our blank screen and we just hit x, it's that number right there. So another way to get your next general solution is add the period. So we get 4.006, which is the same as second trace 5. Scroll over to that next one, however you want to do it, whatever's easier for you. Enter, enter, enter. 4.006. Either way we did that, we get the same answer. You don't want to add pi over 2 to 0.865. You want to add it to the whole number because chances are the decimals are going to be off. And if you are 1/1000th off, it's 1 point. More than that, it's wrong. You have 1/1000th, that means it's a rounding error. If it's not a rounding error, then it's wrong. A rounding error is 1/1000th off. So if you said 2.435, this is irrational, we rounded. This is irrational, pi is an irrational number, meaning you can't write pi as a fraction. It's just always a decimal. So you cannot add rounded answers. If this was whatever plus 90 degrees, then we could add that because it's an irrational number. And whatever your rounded number was to begin with, if we add 90.000, it's going to be exactly the same. And then our last answer here was 5.577. All of those are between 0 and 2 pi. And again, remember the frequency. Answers happen that many times faster. So typically, the parent function of a tangent, there's two places, two quadrants where it's positive. So this one, 2 times 2, that means there's going to be 4 answers in every rotation of the unit circle. If that was a 10, 20 answers. Okay, you can just multiply. That is going to be true for every cycle of the unit circle. This last calculator one, we haven't put this in our calculator yet. Maybe you know how, maybe you don't. Okay, but it is important that you know how to put it because you can't just put that squared on the sign. Okay, that doesn't happen. You hit sign and the parentheses automatically open up. So first, degrees are radians. Well, we're in radians. How do we know? Because of that right there. There's no degree symbol. There's a C value. Now we can't find the period for a squared. We can find the period for sine. We can't find the period for sine squared. So the way we put this in our calculator, and we would never ask you for like the first or the general solutions on this problem. All right, so we would have open parentheses, sine. They automatically open. X minus 1, close, close, squared. So that's what you type into your calculator. And then you find the first 3 positive wherever that graph crosses 2/3. Put 2/3 into y1, y2, y1, y2, see where they cross. And you end up getting, we're in radian mode, so 0.045. 1.955 and 3.186. If you were to find those first 3 positive times that sine squared x minus 1 crosses 2/3. And what I have written right there, that is exactly what you have to type in the calculator. Nothing more, nothing less. Open your parentheses, sine, open parentheses, x minus 1, close, close, squared. If you don't close, close, squared, then that squared goes on the x minus 1, which is a completely different problem. Now you're taking the sine of x squared minus 2x plus 2, and that's not the problem.
So why do you just move the square to the other side? What do you do that?
To the other side?
I mean like take the whole part.
Well, because remember, we have to remember back when we first learned this, sine x. Sine squared x means sine x times sine x, which means sine x squared. You just have to remember that. It's just typically what we do, it's easier to write it there because if you drop those parentheses, then everything changes, and a lot of times y'all don't like writing parentheses. Parentheses seem to drop a lot, just in general, not just y'all, just everywhere. So that is the notation that you see most often. All right, these last two are without a calculator. Notice this is the one I talked about, just like number one, except that instead of equals negative 0.21, where we need a calculator, now it's equals root 3 over 2, so we don't need a calculator. So right here, we could go ahead and say our period is 360 over 2, which is 180. It tells us to use degrees. That's why I use 360 instead of 2 pi. So inverse sine of a side equals an angle. That 2 theta, that's the angle. Now, could we change sine 2 theta into 2 sine theta cosine theta using the double angle? Sure, but no need to do that. That doesn't make any sense. That just makes it impossible to do. Then we just got to change it back so that we can actually work the problem. All right, so there are two places this happens. This left side happens at 60 and at 120. So we can say 60 degrees equals 2 theta, and we can say 120 degrees equals 2 theta. And then it asks for general solutions, so we just divide by 2 and we get our answers. Theta equals 30 degrees plus the period n. Theta equals 60 degrees plus the period n. And there are your general solutions. Remember, the other time you write general solutions, if it doesn't ask, is when the domain is negative infinity to infinity, because there's no way for you to write all answers from negative infinity to infinity. General solutions are the way to do that. And this last one, so this one's a little bit, that 4x, hey, whenever that angle is not just x, hey, it throws a lot of people off. So this problem, sine squared 4x, 4x is the angle, so it's stuck together. Not until I take the inverse can I do anything with that 4. The 4x is stuck together. We can't divide by 4. We can't do anything with it till we're ready to solve the problem. Now, what this is, we have two types of factoring. We have GCF and then we have trinomials. So if I just said x squared plus 3x plus 2, I have a squared, an unsquared, and a constant. So that's when I have to do my x plus 2, x plus 1. Do I have a squared, an unsquared, and a constant here? No, I don't have a constant. There's just 0. There's nothing there. So that would be like x squared plus 3x. X squared plus 3x means I just take out a GCF. So it's even easier than factoring a trinomial. I have a sine squared 4x. 4x is my angle, so it stays with the sine at all times. Sine is nothing. Sine squared is nothing. Sine 4x is something. So I have two like terms here, so I can take out a sine 4x. That leaves me with a sine 4x plus 1 equals 0. Because if I factor something out, if I put it back in, I have to get what I started with. It has to be exactly the same. It has to be equal. I'm just rewriting it. So now you have your two, just like over here. If I set this equal to 0, I could say x equals 0 and x plus 3 equals 0. And I can solve that. This is called the zero product property rule. No such thing as subtracting that 2 and saying the negative 2 product property rule. The sine 4x product property rule, there's no such thing as that. So now I can say sine 4x equals 0 and sine 4x plus 1 equals 0. And now I have two factors that I solve. So I'm going to go ahead and write here inverse sine of 0 equals 4x. Now we have a domain. I'm not thinking about the domain quite yet. The domain is going to affect my answers. When I start writing answers, that's when I have to think about that domain that it gave me. Right now, I've just got to think about where do the answers happen. So, where is y 0? up here at pi over 2, or let's see, no, not at pi over 2, at 0 and at pi. Or 2 pi. You like 2 pi better than 0? Use 2 pi. I just would always start with 0 because I'd rather not subtract if I don't have to. If you like subtracting, terrific. So we can say 0 equals 4x, or we could say pi equals 4x. So if I solve for x, I get x equals 0. If I solve for x, I get x equals pi over 4. So now I'm ready to write my answers. But first, this step right here, I can determine my period. It's 2 pi over b. So my period is 2 pi over 4, which is pi over 2. So answers happen every pi over 2, no matter where you start. So 0, is 0 an answer? Yeah. It is, but does it fall in our domain? No, so we don't include it. So we don't just ignore it. We need to use it to find our answers. We just don't include it in our answer list down here. If that had an equal sign up there, then we'd include it. But there's no equal sign, so it's just everything up to 0. So we take 0, we add 2 pi over 2. Easy, we get pi over 2. Add another pi over 2, we get pi. Add another pi over 2. Add another pi over 2, we get 2 pi. Do we include 2 pi? Nope, because there's no equal sign on the domain given. So we don't have to subtract from 0 because that gives us negative, and we don't have any negatives in our domain. So now we go to pi over 4. That's in our domain. If we subtract, we're too little, so all we have to do is worry about adding pi over 2 to pi over 4. So 1/4 plus 2/4 is 3/4. So 3 pi over 4 plus another 2/4, 5 pi over 4 plus another 2/4, 7 pi over 4 plus another 2/4, 9 pi over 4. 9 over 4 is 2 point something. 2 point something is too big. 8 pi over 4 is as high as we can go. So we're done with that first one. So now we move over to the second factor. Sine 4x equals -1. That means the inverse sine of -1 equals 4x. This happens down here at 3 pi over 2. I saw a lot of people in their quiz say this is 3 pi over 4 down here. I don't know. Equals 4x. Multiply both sides by 1/4, which is dividing by 4. And x equals 3 pi over 8. 3 over 8. So think about my unit circle. If this is 0 and I'm going in 8s, this is 16 pi over 8. So I can answer anything between 0 and 16 pi over 8. 3 is in between, 3 pi over 8 is in between that. So 3 pi over 8 works. Our period has not changed. Once we have two factors like that, your period will be the same. Only time it would be different is if there's a tangent and a cotangent. If you factored out, you took out a tangent or cotangent with a sine, cosine, secant, or cosecant. Only time your period would be different. I add 4 pi over 8, and I get 7 pi over 8. Another 4 pi over 8. Oops. Another 4 pi over 8. And now another 4 pi over 8. More than 16. So we are done. There are all your answers.